A key part of many embedded systems is sensing the environment around us. And that's exactly why I've dropped by ScioSense here to talk to Norbert Breyer to find out more about the new LiDAR technology they've been developing and flow sensors. So hi Norbert, it's lovely to see you here at the ScioSense stand Electronica 2024. It's great to see there's some new products here available from you which you're displaying. But before we get started, I just wanted to learn a little bit more from you about what ScioSense actually does.
Yes, ScioSense is a company for environmental sensing. So this means all the environmental measures that we want to get, like pressure, humidity, temperature, air quality especially, those are captured by our sensors. But we also look on our impact on the environment, especially saving water, saving resources, saving gas, for example. And therefore we have our flow product range that covers that field of sensors in the environmental range.
Now, moving away from sort of those traditional types of sensors for a moment, there's also something new that you've brought onto the market and showing here. It's a time to digital converter. Now, I'm used to talking about analog to digital converter. Tell us what that time to digital converter is.
It's a tricky technology to measure time intervals with very high precision. So the core technology behind is a ring oscillator built of pure CMOS digital inverters. And we send a start pulse into this chain, and when there's a stop signal, we look at the position on the chain, and that finally gives us the time measurement with the precision of picoseconds. This means we can measure the speed of light. The travel time of light in the range of centimeters is something that we can capture with our TDCs, and that's why it's perfect for LiDAR applications, measuring distance with light emission.
Now, over the years, I've worked a lot on crystal oscillators and other types of high accuracy timing applications. It sounds to me like something like this would require a really expensive oven oscillator or something as a time source. Is that the case?
Not at all, not at all. We can use standard 8 megahertz, 10 megahertz reference oscillators. Maybe 10 to 20 ppm precision is fully sufficient. We calibrate our ring oscillator against this reference clock. And when you scale it down, then you will see as we look at picoseconds, time of light, so it's really not needed to have this ultra high precision oscillators.
Yeah. Now, I'm also used to talking about Colpitts oscillators, Wien oscillators, things like that, but I've rarely come across a ring oscillator. There's something in my head that reminds me of the term. Explain a little bit what that is.
This is in the end a chain of inverters. So you send a pulse into this chain. At the very end, the pulse comes back to the input of the chain. And so the pulse travels around in this ring, I would say. And when the stop pulse comes, then you look at the position of your pulse in that ring, and this gives you the precise timing information. And otherwise, in addition, you count, of course, the rotations, and combining these two informations, you get the full time of light information.
Yeah. And what sort of, you mentioned LiDAR as the application. What sort of LiDAR types are there, and where does this part fit into a typical LiDAR?
We are really looking into the classical single beam rotating LiDAR systems or single beam fixed LiDAR systems, because we see that this is still a very strong established market. So even though there's a lot about the static LiDAR systems for autonomous driving, but I think this is still a future market. Today we see the high volumes in this classical single beam rotating LiDAR systems. So you have a start-stop TDC that just measures the time of light for laser pulses spot by spot, and this is what we target with our new TDC, the LTDC X3.
Yeah. Now, LiDAR is quite expensive to buy and also quite bulky in lots of different applications. What current method of implementing the TDC are you replacing with these devices?
In the end, you can replace the complex circuits that do this time of light measurement by typically analog to digital conversion with gates and things like that. So for us, it's a compact design with a QFN32 package, low power consumption. So it's really usable for handheld systems that are battery driven. Nonetheless, the data rate that we can achieve with that chip is extremely high, up to 50 million samples per second.
Yeah.
Sounds a bit too much, but it's needed because with each laser pulse, you do get a lot of reflections. It's not just point that reflects, but think of a wood, for example, a forest with the various trees, so you get many reflections from each tree, and you want to have all this information to get a full, clear image of your environment, and that's where this LTTC really offers the best performance.
I can imagine there's probably plenty of applications, not just in automotive, where LiDAR is obviously linked to autonomous driving, but maybe also in industrial applications. Where do you see this being used?
Especially autonomous robotics. The service robots, whether they're in the warehouses, but also in the hospitals, in the restaurants, all those service robots, they have this simple LiDAR systems just for safety applications. And that's exactly the market that we target with our LTDC X3.
Now, the other product you brought onto the market this year at Electronica is a complete module. In this case, it's a flow sensor. Tell us a little bit more about how you're moving into complete modular sensors.
Yeah, indeed. The technology behind is exactly the same. Might be surprising. So even though it's about flow sensing, here we talk about ultrasonic flow sensing. The technology is again time to digital conversion. What we do, we measure the speed of an ultrasonic burst in whether it travels with or against the flow, and the time difference is proportional to the flow rate. This is exactly what we want to measure. The amazing thing is that here, in the end, we look at picosecond resolution again. In addition, this is typically battery-driven systems, so we need to do this with a very low power consumption. And this is the perfect application for a TDC, and that's how we come into this market. So, and we started indeed with the standard front ends, so offering a solution for all those people that build their own flow sensors, their own tubes, and applying piezoelectronic transducers. But now we started really to have the first own module that offers a complete solution where the people can mount it into their application and read out the volume.
Now, is this flow sensor focused on liquids or gases or both?
This one is on liquids. We initially thought, of course, only about water, but we can use it also for beverages, cooling through liquids. So this is applicable to many liquids that you can think about.
Yeah.
But the applications that we see is water purifiers, water dispensers, filter applications, then also the sanitary equipment, smart water taps, smart toilets. There it's more about then not measuring the flow rate, but detecting leaks. Because with this ultrasonic technology, we can measure very low flow rates. We even can detect dropping waters, taps, I would say. So this is a nice driver for this application.
And so what sort of span of flow rates would that encompass?
So with the current device, the UFM01, so we cover a range from 60 liters per hour to 2,000 liters per hour, so typically a household application. But we want to build a complete family around that, so with bigger diameters, 1 inch, 1.5 inch, but also smaller diameters. Mm-hmm. So in the end, with the technology itself, we could cover a much higher range. So it's just depending on the diameter of the modules that you will then offer.
Yeah. I guess many people would also be a little bit concerned about the robustness of having an electronic system so close to a fluid with the ultrasound as well. Do they come into contact?
No, that's the great advantage of this technology. The UFM01 is a static system, no moving parts, and the transducers have no contact with the liquids. So that's why it's so suitable for beverages, for example, for food applications. Yeah. And this non-contact principle also gives us a long lifetime, so easy maintenance of the system. So there are no rotating parts, like in a turbine meter, for example, we have the propeller rotating, which got stuck after a few years. With ultrasonic technology, you can run for many, many years. Yeah. In smart water meters, typically we talk about 20 years of operation.
Yeah, of course, yeah. Super. Well, thanks ever so much for the update on the ScioSense sensor applications that you're tackling here. And we look forward to coming back again in the future and finding out a little bit more about where those devices have been used and what's been added to the flow meter modules.
Thank you very much. It was my great pleasure to introduce our new products to you. Thank you.
If you've enjoyed my interviews with the movers and shakers from the deep tech industry, follow me, Stuart Cording, the Electronics Reporter.